because yeah, because I had to like prepare it real quick because of the late notice, I think for the purposes of this lesson, use the we can use the what is it, the chat, um and hopefully everyone can get a few sheets of 8.5 by 11 sheets of paper. Sorry to anyone who uses A4 paper or any other size. Hopefully you can find a letter size 8.5 inches by 11 inches, like this, 8.5 by 11. And once you get the, or I guess, um, given the current circumstances of everything around us, um, yeah, given the current circumstances of everything around us, um, I guess it would be good to mention that we um, are learning math not in a void, but we're learning math that could be useful in solving a lot of the injustices in this world, like systemic racism and police violence. And yeah, uh, we recognize that it is our obligation to remember the lives of George Floyd, um, of Ahmaud Arbery, of Breonna Taylor, and um, to make sure that uh, we that we know that we assert that Black Lives Matter, and we can use our math and stuff to uh, and our voices and every privilege that we have to address these issues. And so now, I guess, okay, who has got their 8.5 by 11 sheets of paper? It doesn't have to be like blank. You can have stuff on it. Um, it can be scratch paper. So just want to know, who out of everyone, like, just feel free to uh, type in the chat if you've like say yes or something, if you've got your paper. It's okay. It's okay. Like, I just want to know how many of you have your paper. And okay, so once you have your paper, just like a few sheets of paper, 1, 2, or 3. Um, so this paper is 8.5 inches like this way and 11 inches this way, right? So I want you to try to come up with, so you got 8.5 inches here and 11 inches here. So how do you get 6 inches? So I'll give you a moment to think about that, like fold and do whatever you want with the paper to get 6 inches. And so with the hand raising, I don't with the hand raising, I I don't think that would be productive for this class. So yeah, you can just like type with me. Not notebook paper, because this particular activity it requires 8.5 by 11. And don't use anything else, just use the paper. Yeah, so you have an 8.5 by 11 sheet of paper, and you want to find 6 inches. Yeah, as Erickson wrote in the group chat, using 8.5 paper gets 6 inches. And yeah, don't spam, but yeah, please don't spam, but just like uh let me know when you got it. And just use the paper, right, and get 6 inches. I'll give you like a total of maybe 5 minutes, um but if people get it sooner, then um that's totally fine. Yeah, so how you're doing it, just like think about it, keep that to yourself for now. Don't post it in the chat. Um just use the sheets of paper themselves. Don't use anything else like a ruler or anything, or scissors or anything. Just use the 8.5 by 11 sheets of paper to get 6 inches. Yeah, so please don't type uh the or actually never mind. Just if you finish it, just let me know. Just it doesn't matter what direction, just 6 inches in general. Yeah. So how do you know it's 6 inches? That's a good question. Uh, like use your mind, use your logic. Um, because you know this is 8.5, and you know this is 11. So okay. So since there's a lot of interjection, a lot of spam, and please don't like spam in between the people who say I got it. Just if you got it, like, can you say it again, or like, can you type it again? Yeah, and if anyone has any questions, feel free to message Helen, the TA. Okay, cool. So I'll just choose the first two people to just share with each other how you got it, but on audio only. Okay, so let's see. Okay, um, are people able to unmute themselves? Okay, Wait, so okay, so yeah. Okay, let me see if I can unmute Eric and Chelsea. Wait, and let's see. Wait, yeah, so Eric and Chelsea, are you unmuted? Okay, this technical stuff isn't going to let this to work. But basically, uh like if you can, yeah, if you can just describe in chat how you did it. Okay, so Kevin said fold a corner all the way and you have 2.5 and 8.5 and then fold again. So uh let's see. Okay. So if everyone, okay, so I'm not sure if we can do this because the unmuting thing is a little hard. Um uh or can anyone who is unmuted like say something? Okay, never mind. It seems like everyone is okay, let's see.
No, he's a savage guy.
Wait, so can you say something? Okay, never mind. I don't think this is gonna work. So just try to whatever way you came up with. So some people might have come up with this way, which is you take the 8.5 side and then you fold it like this, and then you have this length remaining here. So this was 11 inches, and now you have 11 minus 8.5, which is 2.5 inches, and then um, this is eight and a half, and then this is 2.5. So you fold this here to get 8.5 minus 2.5, which is 6 inches. So that's a way. I'm assuming that's what some of you meant. Um, if you have 2 sheets of paper, some people take one sheet and then fold it down. Let's see. Take one sheet, fold it. Take one sheet, fold it down this way, and then so originally you had um originally you have 8.5 here and then 8.5 here, so 17 total, and then fold this down here so you get 17 minus 11, which is 6. Right, and some people might have chosen to might have started out the same way. So 11 minus 8.5, which is 2.5, and so you take the 2.5 and then you fold it down to double it. So now this is 2.5 and 2.5, so 5, and then so have 11 minus 5, and you get 6. So that's something some people might have done. And please don't spam the chat. Um, and yeah, that's something some people might have done. Another thing people might have done if they had 3 sheets of paper is to simply have no is to simply not fold at all. Just have 2 of them like this, and then over. So you have 17 inches at the bottom, and then overlay the third sheet of paper on top, and you have 17 minus 11, which is 6. So that's one that doesn't require any folding if you have 3 sheets of paper. Um, so yeah, I hopefully I made it. I tried to make it clear that you can grab a few sheets of paper, but if not, it's okay. You can definitely just use 1 sheet of paper and get 6 inches here. So yeah, actually, I think given okay, so now whatever method that you use to get 6 inches, please all right. So now think of write it down write it down as an expression. So we have 8.5 as the width, which we can call W, and then 11 as the length, which we can call L. So I'll type it in the chat, and people please don't spam. W is the width, which is 8.5, and L is the length, which is 11. And so come up with an expression that describes how you got 6 inches. And when you're done, you can just put it in the chat. Okay, so I see 2W minus L. 2W minus L. I see W minus L minus W. And then let's see what else. I see 11 minus 2 times L minus W equals 6. So 11 is the width, so I'll write that as L. So L minus 2 times L minus W. And then W minus L minus W. Let's see, 3L minus W. W minus L minus W, which was, oh, these two are repeated. So seems like quite a few people use that one. 8.5 minus 11 minus 8.5, which is the same as W minus the L minus W. Okay, so what do you notice about these expressions? Yeah, and feel free to type in the chat if you want. Okay, so the thing is that these expressions are all equal. And they're equal to 6 because we wanted to use the width and the length of the sheet of paper to get 6. So here's a question. What other width and length of paper, for what other width and length of paper can you use the same method that you used here to get 6? And is the chat, oh, I think somehow the chat was turned off. So right here. Yeah, don't send any links, just what what other sheets of paper can you use your same method to get 6? All right, I see 8 by 10. I see 5 by 4, 4 by 10. All right, so let's plug this in to see. 8 by 10. So 2 times 2 times 8 minus 10 is 16 minus 10 is 6. So yeah, 8 by 10 works. 5 by 4, let's see. So 2 times 5 minus 4 is 10 minus 4, which is 6. That works. 16 by 20, so 2 times 16 is 32, minus 20 is 12. That doesn't work. Oh, as someone pointed out, 3L minus W. So let's see how, if if our if our length was 11 and our width was 8.5, then 3L minus W would be 3 times 11, which is 33, minus W, which is 8.5, which is not 6. So yeah, thanks for submitting, but I don't think it works. Okay, so we have two possible paper sizes, 8 by 10 and 5 by 4, which works. So we started with 8.5 by 11, and then we also have 8 by 10, and we also have 5 by 4. So the thing is, if we calculate, if we figure out what W minus L minus W, this equation right here is, it turns out that it's W minus L minus W is just W minus L plus W, because this negative right here makes it positive. So W minus L plus W, and then that just becomes 2L minus W. So that's the same as our original 2W minus L. So those are equal for sure. And then L minus 2L minus W. So this becomes L minus 2L plus 2W. And then that the L minus 2L becomes minus L, so this becomes 2W minus L. So that also is 2W minus L. So it turns out that all the expressions that you gave were equivalent, which is nice because you see different ways of writing the expression. But for now, we'll focus on 2W minus L equals 6. And so how can we see how many other possible side lengths can you have that for which you can apply the same method to get 6 inches. So we have 8.5 by 11. We use that method. We can have a sheet of paper with side lengths 5 and 4, a sheet of paper with side lengths 8 and 10. So yeah, unfortunately the chat got muted again. So hopefully, yeah, please don't type Fortnite, but I'm not going to mute the chat. I want to see what other ideas do you have? Wait, 100 by 192. Let's see, 2 times 100 is 200. And then 192 as L, that gives 200 minus 192, which is 8. That's close. We can use 100 by 194, which would give 200 minus 194, which is 6. I see 10 and 4. Okay, so maybe I'll just allow attendees to chat with host only, because people seem to be distracted by the chat. Okay, so yeah, sorry for that. But okay, so some people said 10 by 14. 10 by 14, 100 by 194. So how many other values can you for W and L can you find? Okay, I see people are saying infinite. So infinitely many values of W and L. And how do we represent this? Yeah, as y'all are pointing out, we can represent this as a line. So if we graph this with W here and L here, then we can see, like, if we call 8.5 by 11, like, say W is 8.5, so we go along this W axis and get 8.5, and then L we can say is 11. So here is a point, and then 5, 4, that's another point. So 5 and 4, somewhere like here, and then 8 by 10, and then 10, we go a little further, so 10 by 14. Yeah, people are also giving a lot of other ordered pairs, and it turns out, like people are saying, this is a line. There are infinitely many values for W and L, which can give you the side length 6. And so the thing is, here we have L is negative. So what happens when L is negative? Yeah, so when L is negative, that means it's a negative side length, which can't be possible, right? So here we don't have the negative part. Yeah, and who knows what point this is? Three by zero. Okay, cool. So this point is 3 by 0 because um, we can just if we have a sheet of paper that's 3 by 0, then it's just a side length 3, and then you can just double it to get 6. And people are also saying you can use 6 by 6, which is another method of getting 6. And you can actually that should lie somewhere here. Yeah, it should lie about here. And so, yeah, as people are saying, 3 by 0 is not necessarily a sheet of paper. But, okay, so we can now see that when we write this as an equation, 2w minus L equals 6, it lets us think of all the different possibilities. For all the positive values of L, we can get a corresponding value of W that allows us to use the same method to get the side length 6. And so yeah, so we can and so that's the power of the equation. Like before, we would have come up with had to test like 5 and 4, 100 and 194, and all these different values. But now we can see that there are infinitely many values that satisfy this. It's a line. And one thing about uh, representing 2w minus L equals 6 is that you get a line, but what if we have another equation? So since this I was assigned to this class, teach this class like pretty recently, I didn't prepare any specific examples, but can anyone come up with some very random other equation? Or like something times L plus something times W equals something. Like 3x plus 5y equals 8. 5w plus 2l equals 10. I'll probably use 5w plus 2l equals 10 because it's already in the form of uh, something times w plus something times l. So, okay, it's okay. You can stop chatting up, and please don't spam. Yeah. Okay. So yeah. So we have 5w plus 2l equals 10, and 2w minus l equals 6. So what does this look like? What does 5w plus 2l equals 10 look like? It looks like another line. So what are some values of w and l that can satisfy this? 5w plus 2l equals 10. Okay, so 1 and 5 halves, 2, 0. Okay, so 2, 0, 1 and 5 halves. That would give us 5 times 1 plus 2 times 5 halves, which is 5 plus 5, which is 10. So that's good. 1 and 5 halves. 2, 0, 0, 5. Okay, that's another one. 5 times 0, 0, plus 2 times 5, 10. So 0, 5. Okay, we can use these for now and get 2 0, 2, 0, which is something like around here. And then 0, 5, which is something like around here. So does any, that was, so does anyone know where these two, what value satisfies both of these equations? 2w minus L equals 6 and 5w plus 2L equals 10. So it turns out the value that satisfies both of these equations is where they meet, is where the lines meet, right here. Okay, so how do we find that? Well, this point where they meet, WL, has to satisfy both of these equations. And what can we do to find W and L that satisfy both of these equations? Well, one thing we can do is to find one of W and L first. And what we can do to find that is, for example, here, it seems like we can get rid of the L pretty easily. So we can find W first and then find L after that. So to get rid of the W, we can double the first equation. So we have 4W minus 2L equals 12. And then add these two. So we get 9W equals 22. And W equals 22 over 9. L equals, from the first equation, we have L equals 6 minus 2W, which is 6 minus 2 times 22 over 9, which is something random that I'm not going to calculate out. Okay, so we see that in two variables, we get two lines that intersect at one point. Is it possible to have two lines that intersect at 0 points? Yes, I see people. Yeah, if two lines are parallel, they can't have any intersection. And if they're the same line, then they have infinitely many. So yeah. So now let's look at the case of three variables. Can anyone give me some examples of equations in, can can people please stop spamming? Okay. Yeah. So someone gave the example of. Wait, I'll just clear the whole thing. So someone gave the example of 3x plus 4y plus 5z equals 65, and so how many solutions are there to this? Well, we can say z, for example, z is 0, then we can make y as big or small as we want, and x as big or small as we want, to satisfy this. So there are infinitely many solutions to this. So we want to have another equation so that we can somehow restrict the number of solutions. Can someone come up with another equation here? Okay, so 3x plus okay, so we can stop now. We can I chose some. Like 3x plus 6y minus 7z equals 45. And then 4x plus 2y minus 8z equals 22. 4x plus 2y minus 8z equals 22. All right, so how many solutions does this have? Well, or how can we start to solve this? So we can what we want to do is to find, yeah, as people are saying, make it two variables. What we can do is to first make it two variables is that we see here's 3x and here's another 3x. So let's see, 3x. So we can cancel that out by subtracting and get 4y minus 3x minus 3x, which is 0. And then 4y minus 6y, which is minus 2y. 5z minus 7z, which is plus 12z, equals 65 minus 45, which is 20. Right? And what else can we do? Someone said make all y coefficients the same, which is a pretty good idea. If we started with the x coefficients, we can first eliminate the x's. So let's see, 3x and 4x, we can somehow make that into, make the first one, multiply the first equation by 4 and get 12x plus 16y plus 20z equals 4 times 65, 2 times 130, 260. And then multiply the last equation by 3 to get 12x wait, my computer is frozen. Okay, there. Yeah, so there are many ways to go about this, as people are mentioning. And then if we multiply the last equation by 3, we have 12x plus 6y minus 24z equals 66. And then we can subtract these two and get 10y plus 44z equals what is it? 260 minus 66 is 194. Okay, and so the thing is that now we have an equation here in two variables and another equation here in two variables equals 194. And so we can easily solve this using the method that we went through before. And yeah, so and so the thing is that this is really not systematic at all. And so one way to make this more systematic is to actually write 3x plus 4y plus 5z equals 65. Write this thing as in a different form. So instead of, so we have here 3, 4, and 5. And that turns out to be the what you get when you multiply the row vector 3, 4, 5 by x, y, z. So this, I'm not sure if this is new for some of you, but it's another way we can write it. And this equals 65. And then this here, 3x plus 6y minus 7z, we can write that as 3, 6, negative 7, 3, 6, negative 7 times x, y, z equals 45. And then this here, we can write it as 4, 2, and negative 8. Times x, y, z equals 22. So in essence, I just wrote it in a different way. But then this actually gives rise to a new method of this actually gives rise to a new method of solving these equations. So when you have something like a, b, c times x, y, z, this is basically the same as ax plus by plus cz. Right? So if we do the same thing as before, then instead of writing x, y, and z all over again, we see that there's this common x, y, z right here down the middle. And so we can, instead of writing this x, y, z, we can just say that the thing on the left multiplied by x, y, z is equal to this column on the right. And this is called a column vector. And this is actually, if we put it all together, we get that this is actually a matrix. And so we approach this in the same way. So so actually what we can have, what we do here is we can say that 4, 2, and negative 8 and 22, they all are divisible by 2, so we can divide by 2 in each. 4, 2, negative 8 becomes 2, 1, and negative 4. And if you have any questions, feel free to ask Helen again. Equals 11. And the other ones can't be reduced as easily, so we can just we'll just work with these for now. Okay. So as with earlier, we can notice that the first and the second one, if we subtract these two, we get 3 minus 3 is 0, so 0. And 4 minus 6 is negative 2. And 5 minus negative 7 is 12. And then 65 minus 45 is 20. And then we can somehow, what is it? We can multiply this last equation by 3.5 to get 3 in order to cancel out this top one. So 3 and then 3.5 times 1 is 3.5. And then 3.5 times negative 4 is negative 6. 3.5 times 11 is 33 over 2. And then we can subtract this from the first to get 3 minus 3 is 0. And then 4 minus 3.5 is 8.5 over minus 3.5, which is 5.5. And then 5 minus 6 is just 11. And then 65 minus 33 over 2 is, so 33 over 2 is 16.5. So that's 38.5. Okay, and then it becomes a system of two equations, just the here. So 5.5 times y plus 11 times z equals 38.5. We can actually multiply the top one by 2 to make things easier. So make this 5 and make this 11 instead, or make 11 22 instead, and make this 38.5, make this into 79, or no, 77. And then so if we multiply the this part by 5, we get negative 10, and then 12 multiplied by 5, we get 60. And then 20 multiplied by 5, we get 100. And then here we get 5, we multiply that by 2, we get 10. 22 multiplied by 2, we get 44. And then 77 multiplied by 2, we get 154. So in the end, when we add these two, we get 104 and 254. Zero, 104, and 254. So now, yeah, it's almost 2. So if you want to leave, you can leave. But basically, now we have 104 times z equals 254. So we can get z. You can get z equals 254 divided by 104. We can get negative 2y plus 12z equals this, and since we have z, since we have z, we can deduce y, just write down this equation and get y, and then after we get y, we can write it here and then get x. So this is just another way, like introduction to linear algebra and using matrices to solve these equations. And as we saw earlier, with two variables, we had two lines, right? Something like this and something like this, and they intersected somewhere. With three variables, we would have three planes. So like a whole plane, something like this, and then another plane. And then that intersection would be a line. And then when you have a final plane cutting through, you would only be left with a point of intersection. So yeah, sorry for all the technical difficulties and all the messiness of this whole lesson, but hopefully we can treat this as a sort of introduction to um, algebra or linear algebra. And yeah, thanks for coming.